pretty clear that we get mitochondrial dysfunction as we age, which is associated with many of the classic features of human aging. Essentially, disorder like SIBM really is an accelerated form of human aging, and people get dramatic muscle atrophy and weakness much earlier on in life with this disorder. And when you look at biopsies from these patients, they look like very aged individuals where we see mitochondrial dysfunction. So when we do a muscle biopsy on any of these disorders, we see the mitochondrial dysfunction reflected in an accumulation of abnormal mitochondria. So these essentially are called paracrystalline inclusions, which are an attempt for the cell, when it's exposed to poor energy output, to make more of the engines called mitochondria and try and extract more energy. Eventually, that becomes a sort of a failed process, and we accumulate these ragged red fibers, and eventually the cell can die. You can see here in the bottom panel, this is what's called a cytochrome C oxidase negative fiber. This is the main component of the mitochondria that extracts oxygen. And these do accumulate with aging, but more so in our patients with different muscle disorders. But it's a classic feature of many, but not all, mitochondrial disease. So failure to find this doesn't mean you don't have a mitochondrial disease, but when you see these, you're thinking it's either primary or secondary. So we've been very interested over the years in looking at how nutrition, nutraceutical compounds, what I call the pharma nutraceutical approach, where we take a pharmacological approach to develop nutraceuticals. And of course, we're very interested in exercise, which I don't have time to talk about tonight. The reason why mitochondrial dysfunction is a targetable entity is that it leads to a variety of issues like oxidative stress, lower protein synthesis, inflammation, and we also get what's called stem cell exhaustion. In muscle, those stem cells are called satellite cells, and we see that we have fewer cells to regenerate our tissues as we get older. So one of the things that we wanted to see, first and foremost, very simple stuff: do patients who have mobility impairments eat enough? And you can imagine if somebody has swallowing issues or they're weak, it's hard to shop, it's hard to cook, and sometimes hard to swallow. So we looked at 51 of our patients in this paper here with myotonic dystrophy, limb-girdle dystrophy, and FSH, and boys with Duchenne. And what we did was we analyzed their diet on 2 separate occasions for 3 days. So 2 weekdays and a weekend day, waited to 5 months later and did it again. We looked at the mean values and we compared it to what's called the Canadian Dietary Reference Intake. You might have heard of the RDA in the US, that's a recommended daily allowance, and they're essentially one and the same thing. So what we found, not unexpectedly, is that if people don't move very much, you don't have to eat very much, because if you keep eating as much as somebody who's walking around a lot, you're going to become obese. So we found that a variety of our patients just weren't getting enough calories. And if you don't take in enough food, it's no surprise that many of the vitamins that are important for human health are deficient. So what these numbers represent is the proportion of people not meeting even the basal requirements in the Canadian and US recommendation. And look at things here like vitamin E, which is an important antioxidant, very low. Vitamin D, these numbers are closer to 100% with the new guidelines, which are much higher, showing that for vitamin D, we actually need slightly higher levels. So we've actually looked at mitochondrial patients as well, and we've done analysis. Again, this is only 9 patients, and we've compared it to our publication in patients with muscular dystrophy. Suffice to say that whatever we're showing for muscular dystrophy, it's pretty much the same thing for patients with mitochondrial disease. Now, I'm going to also highlight a little later issues of obesity. Now, you know that the BMI, you've probably heard, is not the best marker of obesity. I'm going to show that in just a minute. And also a number of our patients seem to be lower in weight. Keep this in mind because I'm going to highlight this a little later in my talk. We've also gone on to measure deficiency states in our patients. So in the maroon here are 62 patients with mitochondrial disease, and these numbers are holding true today. We're now up to several hundred patients. And what we can see here is that we have about 16% of our mitochondrial patients, when they first come to see us, are deficient in vitamin B12. Now, that doesn't mean that you take super large amounts of B12. It means that if they're low, as is the case of 16% of our patients, it should be identified and supplemented. And why that's important is vitamin B12, if it's deficient, can cause neuropathy, it can cause dementia, it can cause a spinal cord issue called myelopathy. So missing the opportunity to treat something is like pouring gasoline on the fire. Folic acid functions very similar to vitamin B12. And look here, we have almost 9% of our patients are deficient in folate. In some of our children, we also measure the folate in the spinal fluid and see that up to 20% of kids have low folate in the CSF. Now, other things like vitamin D here, you can see it's only around 10 to 15%, but with the current guidelines, it's over 95% of our patients are not meeting current guidelines. What this number reflects is the amount of vitamin D in your blood to prevent rickets. So these patients are in the rickets range, which is a bone disease, which most people thought didn't exist anymore because that was back in sort of Victorian England when people with dark skin would come over and not have any sunlight. But we're seeing that up to 12% of our patients actually have rickets level vitamin D deficiency. Now, another thing with respect to diet is some of our patients have swallowing issues. And if you have swallowing issues, you have decreased energy intake, or at least it takes you twice as long to eat or 3 times as long. And one of the issues from a swallowing perspective is that if you do have difficulty swallowing, so for example, when you're eating, you're coughing afterwards or choking, and you're finding it difficult to swallow, especially dry foods, which reflects weakness at the back of your throat, you should consider getting a swallowing study. So this is a picture here of someone chewing on some food that has a dye in it so that we can see it, and they're trying to swallow. What you can see here is a pooling of the food in what's called the vallecula. This is very common in our CPEO patients, and we were one of the first to really describe this. This affects almost 80% of our patients with chronic progressive external ophthalmoplegia. So what can happen is when the food is pooling here, after you're done eating, it'll stay there, and eventually it can fall into your trachea and cause a pneumonia. So it's important to identify this, and there's a whole host of strategies that a speech-language pathologist can do to help you to improve your swallowing. So if you are choking after meals, or you find you're coughing after you're eating solid foods, even sometimes a half an hour later, it's because of this pooling, and you really should get one of these swallowing studies. We generally recommend taking a balanced multivitamin because, as you saw in our previous slide, many patients are insufficient. Now, there's no harm whatsoever, and you're not going to get toxic by taking a balanced multivitamin. These can be purchased, for example, from Costco. There's a multivitamin for men, one for women, one for seniors, and there's chewable vitamins for children. So generally, we would recommend for most people who are not getting adequate calories to take a multivitamin. We do recommend to check for deficiencies, the most common of which are folate, vitamin B12, vitamin D, and also to some extent vitamin E. And if they're deficient, it is low-hanging fruit to treat these things. And keep in mind that it's someone with a mitochondrial disease, or indeed any neurologic disorder, who shows some signs of deterioration. It's not always the disease. And too many doctors think anything that happens is the disease, and they forget about common things like becoming hypothyroid, becoming diabetic, getting a vitamin deficiency. So make sure that these things are checked, and don't just throw every decline down to just the underlying disease. Just a little aside is children who are falling off the growth curve with mitochondrial disease or muscular dystrophy, who can't swallow or maybe aren't taking enough calories. We often resort to a G-tube quite early because we can ensure adequate calories, we can ensure the mitochondrial cocktail, and ensure proper protein and calorie to feed them. For mitochondrial patients, generally we would recommend avoid fasting for prolonged periods. And that sort of made its way into the literature. There's a little bit of a caveat to that because sometimes when you fast for 10 to 12 hours, you activate something called autophagy, which may be of benefit. But I do think for especially our more sensitive children in particular who don't have the same reserves as adults, we would like to try and avoid fasting for long periods of time. So smaller meals are generally easier to digest, give you less GI upset, and it's usually easier for people to get adequate calories if you're having more frequent, smaller meals. Specific to complex 1 deficiency or people with PDH deficiency, we recommend or consider trying a high-fat diet. Now, that doesn't mean a ketogenic diet for everyone, but certainly there was a study several years ago showing patients with isolated complex 1 deficiency had better exercise capacity with a high-fat diet because it can partially bypass the defect. We've mentioned treating the deficiencies, and I'll just highlight a couple of other ones that I think should be checked. One is copper. So copper deficiency can actually cause a problem with the spinal cord called myelopathy. And the other one is ferritin. Ferritin reflects your iron stores. Now, in general, most doctors won't replace iron stores unless you become anemic. Once you're anemic, you've kind of missed the bag, and that means that your hemoglobin stores are down. However, ferritin reflects the total body iron stores, and the mitochondria have what are called iron sulfur clusters. And studies have shown that if you are iron deficient, meaning a ferritin less than 50, your mitochondria are not functioning optimally. So generally, we like to keep the ferritin levels over 50 for optimal mitochondrial health. We also would suggest avoiding excessive alcohol consumption. We've seen in some of our patients with optic atrophy. Now, keep in mind, it's quite extreme. We've had people drinking 18 to 20 drinks a day, which can be toxic to the eye nerve, but in general, probably reasonable to keep it under 2 drinks a day. And also those with MELAS syndrome, we suggest avoiding monosodium glutamate, which sometimes when you go out to certain foods, especially Chinese fast food outlets, sometimes they use MSG, but it's used also in other ethnicities' cooking to enhance flavor, but that can trigger migraines. And keep in mind, too, what your triggers might be if you have migraines. Sometimes red wine, older cheeses can cause migraine headaches. So be particularly careful of that in MELAS patients, because a migraine in a MELAS patient can sometimes lead to strokes and seizures. So what happens when the mitochondria don't work well? And what are some of the cellular consequences and targetable areas that we can look at to try and provide nutraceutical support? So if the mitochondria doesn't work, so for example, if you had a cytochrome B mutation, which affects complex 3 here, normally the mitochondria take the food that we eat, we break it down to what are called reducing equivalents, which are little chunks of potential energy, and these are fed into the mitochondria. When oxygen, is present, then these food particles can eventually be taken apart, we call decarboxylated, and the potential energy can be used to pump these protons into what's called the intermembrane space. In the presence of oxygen, these free radicals, these electrons will flow, and if there's an impairment, it'll form what are called free radicals, which make these reactive oxygen species. Oxidative stress, you might have heard of that term, but these little free radicals are a problem if there's too many of them, because they can damage DNA, protein, and lipids. And so we do know that many patients with mitochondrial disease will get a backflow of these electrons, which ultimately come from food and are needed to generate essentially ATP when oxygen is present. If they backflow, they can make these reactive oxygen species. And that's why most of the mitochondrial cocktails do contain some antioxidants to mop up these free radicals so they don't do their damage. There's a decrease in ATP generation, given that if you can't use the mitochondria, all you have left are very inefficient energy systems, which don't provide the same level of energy. One of them is creatine. So phosphocreatine is one of the energy stores in our brain, muscle, heart, and that provides energy, but it is limited. The only good thing is that we can supplement with creatine and increase that energy store. We also see that the cell tries to compensate by increasing mitochondria. There's a process called apoptosis, which eventually kills the cells, and the cell tries to increase antioxidant enzymes, but eventually they become overwhelmed, and we have to provide exogenous antioxidants in the presence of diet and or nutraceuticals to try and compensate for these increased free radicals. So these are some of the substrates that have been used to target some of the final common pathways. So if, for example, you have a defect at complex 1, people try to bypass the defect. Things like CoQ10, succinate, and riboflavin can partially do this. People have tried to lower lactate. So if you can't use mitochondria, you flux through what's called glycolysis, you make more lactic acid, and people have tried to lower that by putting more of the lactic acid into the mitochondria with a drug called dichloroacetate and thiamine. This failed in clinical trials because it caused damage to the nerves. Thiamine, I think, is a very appropriate and safe therapy. It's a water-soluble vitamin, and certainly anyone with PDH deficiency should be on thiamine. Antioxidants, we've talked before about mopping up the free radicals. Vitamin E, lipoic acid, vitamin C, coenzyme Q10 are all antioxidants. We are the ones who first suggested giving an alternative energy source with creatine, and I'll talk about that. And I don't have time to talk about these other strategies here, but I'm sure Tanya Tavasalo will talk at some point about exercise training. So the first thing that we did back in 1999 was look for mitochondrial and muscle disorders where creatine levels were very low. And if they're low, it makes sense to replace them. So we did find that mitochondrial DNA disorders had very low levels of total and phosphocreatine, muscular dystrophy, and inflammatory muscle disease. So we and others have gone on to see whether supplementing with creatine helps these people who are deficient. So what is creatine? Creatine is made by all of us every single day of our lives from kidney and pancreas to make what's called guanidino acetate, which is taken up from the liver and makes about 1 to 2 grams of creatine per day. We also get creatine from exogenous consumption. So fish is extremely high, and it's estimated that 10% of the Danish and Norwegian population are chronically creatine loaded because they eat so much herring, which has an extremely high concentration of creatine. If you are a vegan vegetarian, you get no creatine whatsoever in your diet, and your endogenous synthesis can't keep up. And they've shown that muscle and brain creatine levels are low. And in those vegan vegetarians, when you give them creatine, it actually improves their mental capacity, cognitive functioning, and problem-solving ability. So what happens with creatine is most of it ends up in muscle to be used to provide energy, but it also decreases muscle protein breakdown. And creatine is eventually broken down in muscle to creatinine and excreted through the kidneys. So the top here is a muscle contracting. When muscles contract, we need energy. So the first buffer for energy is ATP, which we have in very limited reserves in our muscle. Within a fraction of a second, our ATP levels drop, and we have to resynthesize them. So what happens is phosphocreatine exists in the muscle in very large quantities to buffer this. So when ATP is broken down to contract muscle, it is rephosphorylated back to ATP by phosphocreatine. Now, although the concentration is very high in muscle, it still only provides for 8 to 10 seconds of maximal muscle contraction. But what it does is it provides an energy shuttle. So when we start contracting muscle, we get an increase in creatine, which crosses into the mitochondria to actually activate the mitochondria. So there's a very elaborate creatine phosphocreatine shuttle whereby energy stress in the cytosol, or the sort of outer part of the cells, triggers the mitochondria to start respiring. And studies have shown that adding creatine to a cell system turns on mitochondria and gets them respiring. So for this reason, we suggested it would be reasonable to try this in mitochondrial patients based on a whole bunch of observations. People have shown, we and others, that older adults increase their muscle, increase strength and power. Innumerable animal studies have shown in mouse models, including our studies of Lou Gehrig's disease, Huntington's, and Parkinson's. There's a decrease in what's called neurotoxicity, or damage to the neurons. There's a direct and indirect antioxidant effect. And in studies where they make a womb have low oxygen to simulate what happens to poor children who get cerebral palsy, there's much less damage to the brain of animals if you have anoxia in the womb. And people are now talking about supplementing pregnant women with creatine to prevent children from birth trauma. The other thing that's been shown is with stroke. In animal models of stroke, if the animals are given creatine before a stroke, there's much less damage. That's also been shown in head injury as well. So for patients with MELAS, you don't know when you're going to get the stroke, so loading with creatine would seem to make some sense. And studies in the muscular dystrophy mouse showed increases in mitochondrial function. So we've done studies. This is a study of exercise and creatine in older adults. These are men and women over the age of 65 who did an exercise program 3 times per week. And in those supplemented with creatine, you can see that we could increase the muscle creatine levels dramatically, and that was statistically significant. No increase just with training as if you don't take any creatine. And what that meant is they got more muscle mass and they got more strength gains when they were lifting weights. So clearly, anyone who's doing weight training, creatine is just low-hanging fruit. Probably 200 studies have shown similar results, that we can better increase muscle mass and strength if we're exercise training. Now, what if you're not exercise training? This was our first study in patients with mitochondrial disease with just creatine, nothing else in the supplement. And we had 7 patients with MELAS syndrome, randomized crossover. What that means is neither us nor the patients knew what they were on. They took a placebo, they took the drug, or they took drug and placebo. And only after the study was over did we know what they took and we could do the analysis. So they took 10 grams a day, which is essentially 2 heaping teaspoons. And then we put them down to essentially 1 level teaspoon for a week. And what we found was strength went up in both the hand and the foot by about 11%. And this is a fatiguing trial. So we did this on and off for a minute. And what we found is that strength was better maintained. Now, you might say, well, who cares about 11%? That means nothing. But if you're doing repetitive activity, like let's say you were vacuuming for a minute or any type of repetitive activity, if you can get 11% extra bang for your buck, that does have some consequences of benefit. The other way to think about it is in our boys with Duchenne dystrophy, which is a horrible degenerative disease where boys die, we poison them with prednisone. We give them one of the most toxic drugs known to mankind with tons of side effects. Every one of them becomes osteoporotic. They all get cataracts. They all become diabetic and obese later on, and they get a 6% increase in strength. And yet that was deemed to be beneficial enough that we keep giving them this medication. Whereas with creatine, essentially no side effects. Now, it was a short-term study, so we didn't see that their maximal aerobic capacity, which is a reflection of mitochondrial disease, got better. So we and others have used creatine in patients with Duchenne muscular dystrophy. There have been at least 10 studies now throughout the world with over 200 patients now enrolled. The time when I wrote this, there was only 192. But what we found was on average an 8.5% increase in strength and about 1.5 pounds increase in muscle mass.